Another type of problem that showed up in our pre-assessment that a lot of people missed were quadratics, but specifically they were quadratics that were already factored. And this is going to work out a little bit differently than quadratics that aren't already factored. Number one, very much like what I did if you looked at my radicals video, you want to isolate. You're basically working backwards through the order of operations. You're undoing everything that's been done to this variable. So this variable had 2 subtracted from it. Then it's squared. Then it's multiplied by 2. Then 5 is added to it. You've got to undo all that. So we subtract 5. Okay, and you get 2 times the quantity x minus 2 quantity squared is equal to 18. Okay, then you have to undo that multiplying by 2. So you divide both sides by 2. You get the quantity x minus 2 squared is equal to 9. Okay, and at this point, a lot of people were turning this into a quadratic by multiplying this out. They were saying, oh, it's the quantity x minus 2 times the quantity x minus 2, and it equals 9. And they were multiplying this out. They were getting x squared minus 4x plus 4 is equal to 9. And then they were saying, well, you know, do I move the 9 over here? Remember, all the factoring you did, the quadratic formula, that's all there because you've got both an x squared and an x in the equation. Okay? This factored form is very special because it's actually factored in a way in which you only have one variable in the first place. Okay, if you look at this right here. So, yeah, you could do that. Yes, you could try to factor. Yes, you could try to use the quadratic formula. But don't make things harder on yourself than you need to. Okay? The only reason you have those is to deal with equations with maybe an x squared and an x, where you can't combine them together. So if you take a look at this, I just have to undo squaring. I have to take the square root. But you do have to be careful, okay? If I ask you to take a square root normally, remember that there's actually a positive square root and there's a negative square root, okay? The square root symbol is what's referred to as the principal square root. It's a function. So when you take the square root of 25 on your calculator, for example, your calculator is going to give you back 5, okay? If I want to talk about the negative square root, I put a symbol like that, and that would basically work out to be negative 5, okay? But when we're talking about the concept of a square root, we're saying, hey, something is getting squared to give me 9, okay? Well, there are 2 things that could be squared to give you 9, 3 and negative 3, okay? So you do have to be careful. You need to recognize, hey, this is a quadratic. I expect this thing to have 2 answers in most cases, okay? So we take the square root here, and again, the square root of this is going to end up giving us positive or negative 3. Okay? And, of course, the square root knocks out the squaring. We get x minus 2 is equal to either positive 3 or x minus 2 is equal to negative 3. In other words, whatever was in here that was getting squared could have worked out to be a 3, and when it got squared it gave me 9, or it could have worked out to be a negative 3, and when I squared negative 3, I get an answer of 9. Okay? So anyway, you can set up those 2 equations. X minus 2 equals positive 3. And you can set up the equation x minus 2 equals negative 3. And you should be able to get your 2 answers really easily. Add 2 to both sides here, you're going to find out that x is equal to 5. Okay? And if you add 2 to both sides here, you're going to find out that x is equal to negative 1. Okay? Those are your 2 solutions. It saves you the trouble of having to go through the quadratic formula or factoring, something like that. So be on the lookout for that. A factored form is a really good thing, but you have to keep in mind, if it's a quadratic, you might have 2 answers. All right? Let's look at an example with a cube root. Cube roots do work a little bit differently. So what we've got here with the cube root, I've got 2 times the quantity x plus 2 quantity cubed minus 8 is equal to 46. Okay? So same kind of thing. You want to get the exponential part of the equation by itself, working backwards through the order of operations, taking care of addition and subtraction first. I'm going to add 8 to both sides, and that's going to give me 2 times the quantity x plus 2 cubed is equal to 54 when I add 8 to both sides. I can divide both sides by 2. If I divide both sides by 2, I get quantity x plus 2 cubed is equal to 27. Okay? Here's where you have to be careful. There's only one cube root. At least there's only one cube root that's a real number answer. Okay? For example, 2 times 2 times 2 is 8. Negative 2 times negative 2 times negative 2 is negative 8. Okay? So we don't have this 2 answers anymore that we're going to get here. They're actually possibly imaginary solutions, but that's not something we're going to be dealing with in this class. So basically, you just have to say, hey, the opposite of cubing is an odd root. I'm going to take a cube root, and anytime I have an odd root, there's only going to be one answer. Okay, so the cube root of something cubed just leaves me with x plus 2. The cube root of 27 is just 3. You subtract 2 from both sides, and you end up finding out that x is equal to 1. So you undo a square root by squaring. You undo squaring by taking a square root. You undo cubing by taking a cube root. It's a pretty simple pattern, just really working backwards like you did most of the other problems you did in Algebra 1.